Hello, everyone. Good evening, everyone. Am I audible?
Yeah, audible.
Okay, shall we start the session now? Do you have any sessions after 8? Is it revision session only? Is it a revision session or a simple open session? Okay, fine. So let's try to complete it by 8. Okay. So let's go with some topics in week 7 that we have learned. So in week 7, we have the first thing is IID samples. So anyone can you tell me what is the full form of IID?
Independent and identical
Distribution.
Yeah, independent and identical. Okay, so what do you mean by this? What do you mean by independent and identical?
Basically, it follows the same characteristics. It should follow the same characteristics, same distribution.
Yeah, but the sample should be independent of each other. That's the thing. It should be from the same experiment. It should be identical, but the samples that we are drawing from that same experiment should be independent of each other. Okay, that's an independent and identical distribution. Fine. Now, in that topic, we have sample mean.
Can we say that the experiment has to be identical, but the result can be independent outcome? Is that how we should really say?
Yeah, yeah, that's the thing. The experiment should be identical, but the result should be independent of each. Right? Yeah. Okay then. Okay. Then the second topic is sample mean. So what do you mean by sample mean? If we are letting that x1, x2, and xn are IID samples. Okay, they are IID samples. Then we denote sample mean by x bar, and it is defined as x1, that is sum of all the IID samples divided by the number of samples. Okay, so this is a sample mean. And can anyone tell me if this is a random variable or not?
Random variable.
Yeah, and x bar, this is a random variable. Okay. Okay, so why it is called a random variable?
It depends on the
because-
sampling.
Because it is derived from a set of random variables.
Yeah, because the sample mean, like if I have different samples, so I would be having different sample mean. That's why it is a random variable. Fine. Now in this we have expectation of sample mean and variance of sample mean. Okay, so the expectation of sample mean is given as everyone
Mu only.
mu.
Yeah,
Okay,
same.
and variance of sample mean is denoted as
Sigma square by n.
sigma square by n. So this is the expectation and variance of a sample mean. Fine. Okay. Now, here if the value of n increases, then the variance will tend to
0.
0.
0. Yeah, that means the sample mean will take value close to the distribution mean. Like if the values of n is increasing, that means the variance of the sample mean will tend to 0. It also means that the spread of that sample mean will decrease, right? That means the sample mean will be close to the distribution mean. Fine. Is it fine? If we increase the value
Yes,
of
ma'am.
n, what are the things that happens? Okay. Now we have third thing, which is the sample variance. Okay. So what is sample variance? Like if x1, x2, and xn are IID samples. Okay. Then sample variance, it is denoted by capital S square. Okay. And the formula is given as x1 minus x bar whole square plus x2 minus x bar whole square. Similarly, till xn minus x bar whole square divided by n
minus 1.
minus 1. Okay. So here the x bar is the, what is x bar? It is the sample name. Fine. So if x1 and x2 till xn are IID samples, then S square is represented as summation of x1 xi minus x bar whole square divided by n minus 1. Fine. Now here also in sample variance, we have expectation of sample variance also. Okay. So what is expectation of sample variance? It is given by sigma square only. So expectation of sample square is, expectation of sample variance is sigma square, which is the, we can say the population variance. It is equal to the population variance. Fine.
Expectation of sample variance is same as the population variance.
Population, yeah, population variance. Because
But population variance is the sum of all these variances by n, whereas sample variance is sum of all the variances by n minus 1, no, sir?
No. Some population variance is sigma square only. That sigma square n is the variance of x bar.
see, we are finding out the expectation of the sample variance. The expected value of sample variance is equal to the population variance. We are not equating the sample variance is equal, not the sample variance. The expectation of sample variance is equal to the sample square. Okay.
Okay.
Fine. Is it fine?
So this this sigma, sigma, is it variance of x or variance of x bar or variance of
Sigma square. It is the variance of the distribution, you can say, or the population variance. If x,
Sigma square is variance of the IID xi sample.
yeah, these are the see x1 and x2 are the IID samples, which is having a finite variance. Okay, it's having a finite variance sigma square. Okay, so if I calculate the sample variance, okay, if I calculate the sample variance, if I calculate the expected value of the sample variance, it will be equal to the population variance.
okay.
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 Okay. Till now, till here it is fine by everyone.
Okay. What is population variance? Is it same same as actually numerator is same, but instead of n minus 1, we will have n. Is that
N.
correct?
Yeah, that's correct.
Okay.
Yeah, like in we studied in stats 1, S square, sigma square, like sample variance, population variance. We have the formula, right?
Yeah.
Yeah, that's the thing. So sigma square is a population variance in which it is the same formula. Summation of sigma square is what? Summation of xi minus x bar whole square divided by n, right? And what is sample variance? Sample variance is summation of xi minus x bar whole square divided by n minus 1.
Yeah.
Okay, this is the difference between the formula. That's it. Okay, just remember this thing only, that if I have to the expected value of sample variance is equal to the population variance.
So one question, ma'am, here. So in both these cases, the xi is n. Both are same, one and same. Basically,
Sorry,
number of number of samples we are values we are looking at,
Yeah.
is it the same in both the cases?
Yeah, in both the cases it's same.
No, if it is both, if it is the same, then why do we even say one is population variance, other one is sample variance? What I thought was, let's say my population is 1 million and my sample size can be 100 or 1000 or something of that 1 million. So I thought sample is different from the population. Population is much bigger set versus sample. Is that, I mean, so if you can help me clarify that, because I'm getting confused between these two. What is what?
See, the population variance is being the population variance is being calculated from the population, right? And what is sample variance? Sample variance is being calculated from that population. Like from the population, we are having some samples, and from that samples we are calculating the variances, right? That's why we are just dividing it by n-1.
Okay, so though formula looks alike, the number basically n and xi are different. That set is different and this set is different.
Yeah.
Okay.
Is it now fine?
Yeah, I guess so. Yeah, sure.
No, but when he's saying that set is different, this set is different, what does that mean?
Set in the sense from that population, we are just taking out some samples and we are calculating the variances of that sample.
Correct. No, but different means what? See, so like you said, there is a complete population, whatever be the number, say 1 million, 10 million, whatever, that is like historical data, something we have available in our database. Now, every time we won't be working on the entire population, we'll be taking samples from those population and working on that. So these samples are like X1 to Xn IID samples, correct?
Yeah.
And these IID samples are taken from a population which has a finite variance sigma square. Now these n samples which we have drawn, these n samples have the sample mean which is x bar, which is summation xi by n. Now we are defining sample variance with the same, I mean, in the same thing, like how we calculate the variance. Every sample is xi, and we are doing xi minus x bar ka whole square summation. We are not dividing by entire n number of samples, but we are subtracting 1 from the number of samples to calculate sample variance, which is kind of to make it. There was something told in the lecture video that n-1 helps in the entire calculation thing, and basis n-1 we are getting expectation of sample variance as the sigma square itself. If we don't have n-1 in the denominator, then we won't get this expectation. This is all. This is what my understanding is.
Yeah, that's correct. But I think this will be. Is this in the lecture? Like, I don't think so. They have provided.
No, so he had this. Andrew sir has discussed about this n-1 all thing.
Okay, fine. Okay, fine. So let's not go into that deep. Just remember this formula only. The population variance is given by this formula and the sample variance is given by this formula. Fine.
So whenever there is a question on, particularly on sample variance, the word sample will be mentioned, correct? Which will kind of hint towards
it will be, mentioned. Correct. So whenever you have to calculate, like if the question has been asked that you have to calculate the sample variance, then you will use this formula. And if you have to calculate the population variance, you would be using this formula. Okay. Is it fine? Yeah. Can I move forward?
Yes, ma'am.
Then we have the fourth topic, which is the sample. Okay. What is sample proportion? Sample proportion is like if it is denoted by SA, and if like A, like X1 and X2, like X1, X2, Xn are IIT samples, okay, from X population, okay, from the distribution of X. And let us suppose that I'm talking about an event A. So if I have to calculate the sample proportion of an event A, it will be equal to the number of
samples
Times A
occurs.
squares divided by total number of samples.
Yeah, A is true divided by the number of samples. Fine. So if I'm having a samples, let's suppose I'm having sample as like 0, 1, 1, 1, 0. Then what will be the proportion? Like if I have to calculate the proportion that X equals to 1, what is the sample proportion? It will be
3 by 5.
3 by 5. So this is sample. Yeah, this is sample proportion. In this also, we will be calculating the expectation of sample proportion and variance of sample proportion. So expectation of sample proportion will be equal to probability of A. Here, PA is denoting the probability of A. So if I suppose like if I'm considering X1 and X2 are IIT samples, okay, from a distribution of X, and A be an event, okay, then I'm denoting PA as the probability of event A. Okay, then the expected value of the sample proportion A will be equal to the probability of that event A. And if I have to calculate the variance will be equal to probability of A 1 minus probability of A divided by N. Okay. So this is the formula of expectation of sample proportion and variance of sample proportion. Is it fine?
Yes.
The expectation of sample proportion is simply the values that honor the event A by total.
Sorry, what?
The values in the sample that satisfy the event A by total number of whatever samples or events. Is that correct? Here in this case 3 by 5.
Yeah, here in this case 3 by 5, because how many times X is equals to 1? It is 3 times, right? So the number of times that the event A is true, that means X equals to 1 is true is 3 times, and total number of samples are there 5. That is 3 by 5. Right?
Okay, so sample proportion is 3 by 5, as well as expected value of sample proportion is also 3 by 5 in this case. Is that correct?
Sorry, what?
No, sample proportion of X equal to 1 is 3 by 5, and expected value of sample proportion A is also 3 by 5.
Proportion is the probability.
Yeah.
This is the probability of the event.
Correct. Even expected probability of that event. So expected value of sample proportion is 3 by 5 only here, here.
Yeah, this will be 3 by 5. Because probability of happening of an event A is 3 by 5, right? So expected value will also be equal to 3 by 5. Is it fine?
Yeah, so this is going to be true in each and every case. Correct? This.
Yeah, this.
Okay.
Okay. Shall we move forward?
Maybe just to restate it, the expectation of the sample proportion is always a probability of the same event.
So probability of that event. Yeah.
Okay.
Okay. Now we have a topic which is expected value and variance. Okay. So if I'm considering X1, X2, till xn a random variable. Okay, and I'm considering S as the sum of all these random variables. Okay, then the expected value of S will be equal to, that means expectation of, like in place of S, I'm putting x1 plus x2 till xn. So I can write it as expectation of x1 plus expectation of x2 till expectation of xn. So if you have been given that x1 and x2, like they are all random variables, and if I have to find the expectation of sum of all these random variables, it will be equal to the sum of all the expectation of individual random variables. Fine? Is this formula fine?
Yes, ma'am.
Yes.
Yeah. And now if I have to calculate the variance of this sum of random variables, this will be equal to variance of x1 plus variance of x2 till variance of xn. And this condition will only be true when they are uncorrelated. Fine? What do you mean by
independent?
Yeah, like means that they are independent. When they are independent, only this formula will be used.
So by default, if they don't specify independent or not independent,
Now they would be specifying.
okay.
Yeah, they would be specifying if they are correlated or uncorrelated, then only you will use this formula. Okay. Now there are some extensions to it. Like if I say S is equals to A1 x1 plus A2 x2, means A1 and A2 are like some constants. Okay, then the expectation of S will be equal to A1 expectation of x1 plus A2 expectation of x2. Similarly, An expectation of xn. Is it fine?
Yes.
We just added
Yes.
the constants. Okay, then the variance will be equal to what?
A1 square E.
A1 square variance of x1 plus A2 square variance of x2 till An square variance of x. Right? Now, if I considering these x1, x2, xn, they are all IID samples. Then expectation of S will be equal to
Sum of coefficients,
sum of coefficients
expectation of xi.
of x. Right? Because all these values, see, all these are IID samples. So this will be equal to this will be equal to this. So that means expectation of x only, right? So this, like I can write it as A1 expectation of x plus A2 expectation of x plus similarly till An expectation of x. So I'm taking out expectation of x common. So this will be A1 plus An into expectation of x. Is it fine?
Yes.
Right? Similarly, the variance of S will be equal to A1 square, An square into variance of x. Fine? Is it fine?
Yes.
Okay. Now, let's suppose, like if I, x bar is denoting the sample mean. Okay. For this IIT samples only, x bar is, the formula of x bar is written as this. So now if I have to calculate the expectation of x bar, this would be equal to
The mu, which we get.
Yeah, which will be equal to the expectation of x only, and the variance of x bar would be equal to
Sigma square n.
Sigma square.
square by n, that is variance of x divided by n. Okay. So everybody understood till this much?
Yeah, maybe the last step, can you say the variance?
Which one?
Variance calculation, last one. Yeah.
This one.
Yeah. Sigma squared.
Sigma
n
square by n. Sigma square is the variance of the variance of x. That is the from
individual ones. Okay.
Yeah,
Okay.
the
Yeah,
original
dividing.
one divided
got
by
it.
the n. Okay,
Got it.
it's the same thing. Like the variance of a sample mean is equal to sigma square by n only, right?
Correct. For n number of samples, so we are dividing by that.
Yeah, correct. Okay, now here comes the last thing, which is WLN, that is weak law of large numbers. Okay, so what does it states that if I have to calculate, like if I have to we calculate the variance to know the spread, right? Like how how the values are spread from the mean, correct? So if I have to calculate numerically how the if I have to calculate numerically how close the sample mean and the distribution mean are, so I use the WLN, that is the weak law of large number. So it states that the probability of the difference between the sample mean and the actual mean greater than some constant, okay, is always less than equal to sigma square by n delta square. Is it fine?
So here, instead of x mean, can we use x mem or no?
X.
The probability of x
That's
deviating from mean.
That's the Chebyshev's equality. Like
Okay.
it's the shapes. It's the same. The Chebyshev's inequality. What is Chebyshev's inequality? Probability of x minus mu greater than some value, some epsilon, is always less than the variance of x divided by the epsilon square, right? This is the thing. Chebyshev's inequality.
Yeah.
Right? So here we are just finding out the x bar sample mean. This is only the sample, right? We are calculating the sample mean. So in in place of x, we are just replacing it with x bar, right? So this will be equal to probability of x bar minus mu greater than in epsilon like delta less than equal to the variance of x bar would be equal to sigma square by n, right? And epsilon square, that is delta square. That's it. We are just replacing the terms. Is this theorem fine?
Yes, ma'am.
Sure.
Can you repeat about when do we use that one? Weak law of this one.
Okay, so weak law of large numbers states that the probability of the difference between the sample mean and the actual mean greater than some value will be always less than sigma square by n delta square. That means this is a bound. This is the upper bound.
Okay.
So here we are calculating the upper bound. Right?
Sure.
Like what is the probability of the difference between the sample mean and the actual mean greater than some value? What is that probability? So we are just calculating the upper bound.
Okay.
Similarly, we have other forms, which is the probability of x bar minus mu less than some value will always be greater than equal to 1 minus sigma square by n delta square. And this here is the lower bound.
Okay. Sure.
Okay.
Sure.
Fine.
Yeah. Thank you.
Okay. Now this was from week 7. This was some of the topics that will be helpful in quiz 2. Okay. So let's solve some questions. Like in the topics, is anybody having any doubts? These are the main topics that you have to remember. Just remember the formulas and all. And when you solve any questions of WLN, just read the questions and just write somewhere this formula. Okay, just write somewhere this formula, and with the help of the questions, just put the values in it. Then it will be really helpful to solve the question. Fine. Okay, so let's solve some of the questions. Okay. See, a random sample of size 64 is collected from a normal population
Ma'am, can you increase the font, please? Because we are seeing a small screen here. Yeah.
Okay. Now is it fine?
Yeah. Thank you.
A random sample of size 64 is collected from a normal population with mean mu and variance sigma square. So we have been given a sample size which is 64, right? Now, suppose the expected value and the variance of the sample mean is 40 and 0.16 respectively. So can you tell me what are the values that is given?
Mu is 40.
That means the expected value of x is 40. Then
Variance is 0.16.
Sigma square by n.
variance of what?
X bar.
X bar, right? So variance of x bar is 0.16. That means sigma square by n, the value of sigma square by n is 0.16. Now we have to calculate the value of mu plus 5.
One doubt, ma'am. So
Yeah.
here you're saying, when it comes to variance, you're saying the given value is variance of x bar. But expected value, you are using x.
Yeah, because it is only saying expected value, that's it. And this is the variance of the sample. This is one sentence and this is one another sentence.
No, I think it
I
should
was
be
thinking that
x bar only.
expected value and the variance of sample mean. So even the expected value is of x bar only is what I am thinking.
Even then the answer would be same.
Yeah,
Both are
yeah.
new.
This is one. Sorry, got it wrong. This is one only. So expectation of x bar is also 40 and variance of x bar is 0.16. And you know that the expectation of sample mean is equal to
Dx, expectation of x.
mu only. That means the expectation of x only. So this value is equal to 40 only.
Yeah.
Yes.
Yes, ma'am.
Yeah.
Now the variance of sample mean is equals to 0.16. That means it is equal to sigma square by n.
Yes.
Yes.
Now we have to calculate, we have to find the value of mu plus 5 sigma. We have the value of mu.
Ma'am, okay. Yeah.
Yeah, tell me.
No. Please carry on. I think I'll ask you if I have it.
Okay, fine. So you have to find the value of mu plus 5 sigma. So this mu, the value of mu is given. What is the value of mu?
40.
40. Now we have to calculate the value of sigma. So how we will calculate? We know this equation, right? With the help of this equation, we can find out the value of sigma. Sigma
Sigma square,
means
yeah.
sigma square by n is equals to 0.16. The value of n is 64, right?
64.
So sigma square will be 0.16 into 64. So if I calculate sigma, like if I take the square root of this, that is square root of 0.16 into 64, this will be equal to 3.2 if you calculate. Okay? Like you can,
Yes, ma'am.
it's fine. Okay. Now we have the value of sigma. Now we can put this value here also. So the value will be mu plus
16.
5 sigma is equals to 40 plus 5 into 3.2. This will be equal to 40 plus 16, which will be equal
Yes.
to 56.
Okay.
Is it fine?
Yes.
Question fine by everyone?
Yes.
Yes.
Yeah. Anybody having doubts in this question?
No, ma'am.
Okay. Now let's go to another question. Now, suppose that x1, x2, and x3, x4 are IID samples, okay, from a Bernoulli distribution 3 by 5. So if it's a Bernoulli distribution, this value is the value of
Success.
the value of success, or you can say the value of P. Okay, so P is equals to 3 by 5. Okay, now we are defining a random variable y is equals to 2x1. So here y is equals to 2x1 plus 3x2 plus 4x3 plus 5x. We have to find out the value of expectation of y. So what will be the value of expectation of y? Like if you are not able to do is just
Sum of all these
fix the
things.
value of y with this. So this will be equal to expectation of 2x1 plus 3x2 plus 4x3 plus 5x4. So if like in any question you have to calculate the expectation of any value, any random variable, just put that the value of that random variable. Okay, the equation of that random variable. So it will be easy for you to solve it. Right? So this will be now we will take the expectation inside the bracket. Okay, so 2, this is a constant, right? So this will be equal to 2 into expectation of x1, right?
Yes.
Yeah.
This will be equal to 3 into expectation of x2 plus 4 into expectation of x3 plus 5 into expectation of x4, right?
Yeah, ma'am.
Correct. So now these are all random IID random variables, right? So we know that if x1 and xn are IID random variables, then the
Identical
expectation of set was
expectation.
a1 till an into expectation of x, right? This
Yes.
was the formula, right? So I can write it as 2 plus 3 plus 4 plus 5 into expectation of x, right? I can write it as this.
Yes, sir.
Yes, sir.
Sure. Okay. Now this will be equal to 2 plus 3, 5, 14.
14.
To expectation of x is
Mu.
3 by 5.
that is 3 by 5. Okay. So just calculate this. So we will get
8.2.
8.4.
4.
8.4. Yeah.
okay. Is this clear how to calculate the expectation of x? Oh, sorry, y?
Yes.
3 by 5, can you say again? 3 by 5 alone.
Sorry, what?
EFX, 3 by 5, is it given there somewhere?
See, this x1, x2,
Oh, got
x4
it.
are IID from Bernoulli, right? And if for a Bernoulli, the expected value is P only.
Got it. Yeah.
Yeah, that's it.
Thank you.
Now you can find the variance of y also. This will be equal to, variance of y will be equal to, it will be equal to 2 square plus 3 square, 4 square, 5 square into variance of y, sorry, x, correct?
Correct.
Yes.
Everyone?
Yes, ma'am.
Okay. So this will be equal to 4
54.
plus 9 plus 16 plus 25 into variance of x, which is 54 into variance of x. And what is the value of variance of x?
P
If it's
minus 1 by
Bernoulli,
1 minus.
that is
3 by 5 into 2 by 5.
it will be 3 by 5 into 2 by 5. Correct? So the value will be equal to
12.96.
1.6.
Ma'am, can you tell me?
Sorry? Okay.
Ma'am.
Yeah.
Can you tell me how 2 by 5 came?
See, the variance of x, it's a Bernoulli distribution, so variance of x will be equal to P into Q. Right?
Yes.
Okay. So the value of P here, according to the question, is 3 by 5.
Yes.
And what is Q? Q is 1 minus P.
Yes. 2 by 5. Okay.
Yeah. So 1 by minus 3 by 5, it is 2 by 5.
Okay. Thank you, ma'am.
Okay. Now, the third question. Using Chebyshev's inequality, find an upper bound for expectation of x bar minus mu greater than 0.2, where x bar is the sample mu. Okay. So here we are using Chebyshev's inequality. Okay. In the question, it is given Chebyshev's inequality. This is also equal to WLN, right? It is the same from the Chebyshev's inequality. We are having the WLN formula, right? So what is the equation of weak law of large number? It was probability of
x bar minus mu.
Or minus
X bar minus
X bar minus mu
mu greater than
Delta.
greater than delta,
Hmm.
less than or equals to sigma square
by
upon
n into
And delta square.
n delta square.
delta square.
Is this correct? Just take a few minutes and see if it's correct. Right? Okay. Now it's given that. So according to the question, it is X. This should be the probability. So probability X bar minus mu greater than 0.2. Right? This is the question that it is given. So we have to find an upper bound here. Okay. So that means we have to find out this value. Right? And this value is equal to sigma square by n delta square.
Yeah.
Right? So if you compare both of these equations, we see that the value of delta is
Greater than 0 to
the value of delta is 0.2, right? So now we'll find out this value, right? So this is equal to sigma square n delta square, right? That is the value of sigma square will be
12.96.
12.96.
sorry.
12.96.
No, you have to calculate the variance of x.
6
the
by
variance of
25.
X bar.
6 by 25.
Yeah. Correct. Everybody got it? Why it is 6 by 25?
Can you explain?
Everybody got it? Why it
Can you,
the
no,
value
no.
of
Can you
sigma square?
explain that once again?
P into 1
Why-
minus P.
I got that one, but
Here the variance is the variance of x. Okay, variance of x is 3 by 5 into 2 by 5, which is 6 by 25. Okay, here we are not calculating the value of y, we are calculating the value of x. Okay,
okay.
so the variance of x is sigma square, 6 by 25 into what is the value of n? It is 4, right?
Yes, ma'am.
The samples are here. If you see in the question, it is x1 plus x2 plus x3 plus x4 divided by 4. This is the value of n only, right?
Yes.
Correct. Okay. So 6 by 25 into 4. This is the value of n into delta square. The value of delta is
0.2.
0.2, right? So this will be equal to 6 by 25 into 4 into 0.04. So this will be equal to 1 by 1.5. That means the probability of x bar minus mu greater than 0.2 is less than equal to 1.5. So this is the upper bound. Is it fine?
Ma'am, how can it be more than 1, ma'am? Probability should be less than 1, right?
Yeah, this should be. I think the
Somewhere something is wrong actually.
I think the variance part, I think it should be.
no, the variance part is not wrong. I think the question is wrong somewhat. This value is wrong something. Okay. The way I think the this value is wrong.
Yes, because this like 0.2 is very far away from the
Yeah, correct.
expectations.
0.2 is very far away from
Let's take it
expectation.
one
From
only.
the sample mean, the 0.2 is
Yeah.
very different from that.
Let's take it one only. Okay. Let's take this as 1. Fine. Let's take this as 1.
But
Like it's just the probability that if it is greater than 1 or not. That's it. So just look at the process that we are doing, like how to calculate the values. That's the main thing. Okay. So if I have to calculate the probability of this will be equal to 1. This is 1. Right. So if I calculate the value, so this will be
0.06.
0.06. I will check the question. What was the question? But okay, fine. So you got the process how to calculate it?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So this is the it is 1 here. Okay, it is not 0.2, it is 1. So the probability that x bar minus mu is greater than 1, what is that probability? If you have to calculate that upper bound, it will be sigma square by n delta square. Just putting up the values of this, we will get the upper bound. Like if I told that I have to calculate the lower bound, then which formula I would be using?
1 minus upper bound.
1 minus
X bar minus mu less than delta greater than equal to 1 minus sigma square n delta square. Right? This will be the formula that I will be using. Correct?
Yes.
Ma'am?
Yes.
Ma'am, is that the variance calculation is right, ma'am? 6 by 25 the whole divided by 4 into sigma square. Is this right, ma'am?
So, sorry, what?
In that variance of x, we put now 6 by 25. Whole divided by 4 into 0.2 square.
Yeah, correct.
That is actually, that part is correct only. Sigma square.
One calculation is what we missed. Sorry. But we changed from 0.2 to 1, right?
Yeah, that was a mistake. Like in place of 0.2, we are just writing it 1. Okay, I just replace the number, it is 1. Fine?
Sorry. Where it's given, actually, am I missing anything there? Why we are giving 1 instead of 0.2? Because the delta is 0.2, right? It's given the question.
Ma'am, why it can't be less than 1.5?
The delta should be more than sigma by n, root n.
Okay, ma'am.
Means if you convert it into Chebyshev form, you will get delta should be more than sigma by root n.
There's, I think something is wrong actually somewhere. I don't know, values are, issues with the values or question, something somewhere is fishy.
Next question.
Okay, I will come to this question later. Okay, let me see to that.
Yeah, sure, ma'am.
Okay, fine.
Okay, next question.
Okay, now a random sample of size 300 is collected from a population with standard deviation of 20. Okay, so here the random sample of size n is given, the size n, which is n is equals to 300. Okay, with a population with a standard deviation, that means we have been given the sigma square, which is sigma 20. Okay, find a lower bound on the probability. Now here we have to find out the lower bound on the probability that the sample mean will be almost 4 away from the actual mean. That is, we have to find out the probability that x bar minus mu
Less than 4.
Less than 4
is
greater than.
we have to find out this probability, right? And this will be greater than equal to 1 minus sigma square n delta square. Right? So now just put the formula, put the values only. 1 minus, this will be
Sigma square is 20 square.
20 square, that is 400
by 300.
300
into delta square is 4 square.
16. equal to
1 by 12.
that is 11 by 12, right? Some 0 point something, right? So this is the lower bound, that is 11 by 12. Is this fine?
Yeah.
Yes.
Is the question fine? Okay. So if you have to calculate the lower bound, you will use this formula. And if you have to calculate the upper bound, you will use x bar minus mu greater than some value. It should be less than equal to sigma square by n delta square. Is it fine?
Yes.
Okay. Fine. So all these three questions are clear for everyone? Like how to solve the question?
Yes, clear.
Okay.
Yes, clear, ma'am.
Now let's come to week 8. Okay. So in week 8, the two main topics are the MGF and the central limit theorem. These are the two main topics. Okay. So what is MGF? Anybody?
So moment generating function.
Hmm.
So
So like for what we use this?
it is for generating the first and second, third, etc. All the moments of
All the moments. Yeah. So so let us suppose that x is a zero mean random variable. Okay. Then let us suppose that mx lambda is a function which is going from real number to real number. Okay. So this is a function which is going from real number to real number. Then mx lambda is given as expectation of e raised to the power lambda x. Okay. So what is the formula of moment mgf of x, which is expectation of e raised to the power lambda x, right? And you can say it as mx lambda is equal to, this is the expectation, right? See, the expectation of x is given as summation of x into the probability of x, right? This was the formula of expectation, a simple formula of expectation of x.
Yes, ma'am.
Right? So similarly, so expectation of e raised to the power lambda x, this will be equal to summation of e raised to the power lambda x into the function of x here I let's okay, this is going from 1 to infinity. Let's okay. So this mx lambda will be equal to summation of e raised to the power lambda xi into the function of xi.
Yeah.
Correct? Right? So let's, for example, let's say if the value of x is -1, 0, and 2. Okay. And these are the probability. For -1, the probability is 1 by 2. For 0, the probability is 1 by 4. And for 2, the probability is 1 by 4. So if I have to calculate the moment generating function of x, it would be equal to expectation of e raised to the power lambda x. This is equal to summation of e raised to the power lambda x into function of x, right? Now, so x is going from -1, 0, and 2. So e raised to the power lambda. So x1 will be, this is x1, this is x2, and this is x3, right? So e raised to the power lambda, what is the value of x1?
-1.
-1 into the function of x, or you can say the probability, which is 1 by 2.
1 by 2.
Right? Plus e raised to the power lambda, the value of x2 is
0.
0 into the probability, which is 1 by 4.
1 by
Okay?
4.
Plus e raised to the power lambda x3 is 2 into probability of 2, which is 1 by 2.
1 by
So I can
4.
write it as 1 by 2 e raised to the power minus lambda plus 1 by 4 plus e raised to the power 1 by 4 into e raised to the power 2 lambda. Is it fine?
Yes.
Yes.
How to calculate a movement generative function? Let's take another example.
Ma'am, if the variable is not adjusted to 0 mean, then do we have to do that, or?
Yeah, we can do that. Just subtract it from the expected values.
Okay,
It will be 0. Yeah.
So x has to be always 0.
Zero mean random variable.
Okay, otherwise this is not applicable.
No. Right? Okay, let's take another example. This x is a random variable taking values minus p and 1 minus p. Okay, and the probabilities are for minus p, it is 1 minus p, and for 1 minus p, the probability is p. So what will be the moment generating function?
E power minus px, e power minus p into 1
Lambda.
minus p. Yeah, okay.
Lambda into 1 minus
Minus p.
plus
P.
E to the power
1 minus p lambda.
1 minus p lambda.
I mean, I think we have to have minus p.
into p.
Into p. Right?
Yeah.
So just you can write it as like this. Is it fine?
Ma'am,
Yes,
I think the second term, e to the power of 1 minus p lambda, should have minus before it.
Why?
Oh, e power lambda x. Oh, okay.
See,
Sorry.
mx lambda is summation of e raised to the power lambda x into the function of x. Right?
Yeah, sorry.
Yeah, sorry. Now, if like in case I have been given a marginal distribution, say like this, I have been given a marginal distribution mx lambda as 1 by 3 e raised to the power 3 lambda by 2 plus 1 by 6 e raised to the power minus 3 lambda plus 1 by 8 e raised to the power minus lambda plus 1 by 8 into e raised to the power lambda plus 1 by 4 e raised to the power 1 by 4. Okay, if I have been given a moment generative function, from that can I can I have the distribution? Like, can I know the distribution?
Yes.
Yes, ma'am.
Yeah? So see, this is equal to summation of e raised to the power lambda x into function of x, or you can say the probability, right? So the values that x are taking are, these are the values, right? So this will be 3 by 2
minus 3
minus 3
minus 3
minus 1
1
1 by 4.
0.
No, 0.
0, correct, because this is e raised to the power lambda into 0, right? So
ma'am,
minus 3.
I'm sorry to disturb.
10.
Hello. Yeah. So can we say this x is the zero mean random variable? So whatever the x or the random variable that we are generating from using the moment generating function,
yeah, they are all, they
would be
will
the
be
zero mean, right?
Yeah, they will be zero mean random variable.
Thank you.
So yeah, so these are the distribution. And what are the probabilities for minus 3? The probability is
1 by 6.
1 by 6 for minus 1.
1 by 8.
1 by 8 for 0.
1 by 4.
For 1.
1 by 8.
Yeah, and for 3 by
1
2.
by 3. 1 by 3.
Is it fine?
Yes, ma'am.
Okay. Now, And the most important thing that you have to remember is that if x is following a normal distribution 0, sigma square, then the MGF is given as
Ma'am, in the
e to the power.
earlier example, x is not the zero mean random variable, right? If we calculate the mean of the sample, it is not zero actually.
We can make it 0 by just subtracted by the expected value.
No,
Then
no,
it
ma'am.
will be 0.
No, ma'am. Actually, we don't have to. It is the given given values are leading to zero mean only, because
Zero mean.
you have to use the probability also. You have to multiply the x value with the probability, corresponding probability, and then sum up all those things. Then you will get 0.
Okay, okay, thank you.
Okay, then.
Thanks, madam. You can proceed.
Yeah. Okay. So the thing is that you have to remember is, if if x is following a normal distribution 0, sigma square, then the moment generating function is given as
e to the power lambda square sigma square divided by 2.
Yes. So this is the most important thing that you have to remember. This is the formula that you have to remember. This will help you in solving the questions. Fine. Okay. Now, we know that the moment generating function, the formula of moment generating function is expectation of e raised to the power lambda x. Right? Now, before that, the e raised to the power lambda x is, the formula is 1 plus lambda x plus lambda square x square divided by
factorial of 2.
Correct. Plus lambda cube
x cube divided by 3 factorial.
Yeah, similarly like that. Okay. So if I have to calculate this expected value, this will be expectation of 1 plus lambda x plus lambda square x square by 2 factorial plus lambda cube x cube by 3 factorial, like that, right? So this will be equal, like if I take the expectation inside the brackets, so expectation of 1 will be normally lambda is a constant, so this will be lambda into expectation of x, right? Yes.
Yes, ma'am.
Right, and lambda square expectation of x square by 2 factorial, expectation of x square plus lambda cube by 3 factorial expectation of x cube. Okay, so now here we are using the moment generating function to calculate the moments. So here if we see, this expectation of x is the first moment. Okay, this expectation of x square is the second moment. Okay, similarly x cube is the third moment. Okay, so with the help of moment generating function, we can calculate the first movement, the second movement, and the third movement. Okay, and this first movement, second movement, and third movement is equal to, this is equal to the coefficients, right? The coefficient of first movement is lambda. The coefficient of second movement is lambda square. And the coefficient of third movement is lambda cube by
3 factorial.
3 factorial, right? So the first movement, like from the coefficient, you can have the values of the first movement, second movement, and third movement. So if I have to calculate the moments, expectation of xi, this will be equal to lambda raised to the power I upon factorial I. Correct?
Submission नहीं आया हमें. Submission.
Okay, so if I have to calculate the expectation of X, like if I have to calculate the moments of e raised to the power lambda or e raised to the power of xi, this will be equal to summation of lambda I upon factorial I.
Ma'am, not clear, ma'am. Something.
Not, just a second, just a second. Something.
Now, what the summation will be? They are finding the coefficients of the moment, right?
Yeah.
What is the need for summation?
Okay, just forget about this. I will
Here we are looking at a single variable x.
We are just yeah.
And if we want to look for
correct.
x1, x2,
yeah, we are just looking for the single value. If I have to calculate the moments, so if I'm given an equation like this, okay, and if like in place of expectation of x, I have some values like you can say like for example, if I have x as a normal, like if x is following a normal distribution 0, sigma square, and I have been given the you can say the moment generating function as 1 plus lambda 1 plus lambda square by 2 factorial into sigma square plus lambda 4 upon factorial 4 factorial 4 into 3 sigma 4. So like that, if I am given an equation, so you have to find out the expectation of x, right? So according to this equation, the coefficient of expectation x is lambda, right? But here the coefficient there is no lambda. That means the coefficient of lambda is 0.
Yes.
See, if you want.
Ma'am, do we say coefficient of lambda or say coefficient of first movement?
So it's coefficient of first movement. So I can write it as 1 plus lambda into 0 plus lambda square factorial 2 sigma square plus lambda 3 to factorial 3 into 0 plus like that, right? So if I have to find out the like the first movement, that is the expectation of x, right? So this will be equal to 0. So coefficient of lambda is first movement, right?
Yes, ma'am.
Then if I have to find out expectation of x square, so coefficient of lambda square by 2 factorial is
Sigma square.
Sigma square.
This will be the second movement. Then if I have to find out expectation of x cube, that is the third movement. So I will look into the coefficient of lambda cube by factorial 3, which will be 0. It is 0, right?
Yes, ma'am.
Okay. Similarly, if like if you see, it was lambda 4 upon 4 factorial into 3 sigma 4, right? So expectation of x4 will be equal to
3 sigma square by 4. Sigma power 4.
Yeah. Is it fine? So just look to the coefficients. Okay. So for expectation of x, just look at the coefficient of lambda. Then for x square, lambda square by factorial 2. Then coefficient of the coefficient lambda cube by factorial 3, and the coefficient lambda 4 by factorial 4 for all the 4 movements. Fine.
Ma'am, why did we not write the denominator part here?
Denominator? Which denominator?
Yeah, expected value of x4 is 3 sigma 4. By so factorial 4 is
that is not the coefficient. That is the value of e raised to x to the power 4.
This is the whole value.
That is the coefficient.
That's the coefficient that you have to see. You have to see the coefficient lambda 4. See, you have to see the coefficient lambda I raised upon factorial I.
Yes,
Okay, so like you can see, expectation of xi will be equal to lambda I upon factorial I. So if I have to see expectation of x1, this will be equal to lambda raised to the power 1 upon factorial 1. Fine. Similarly, if I have to see expectation of x square, right? So this will be equal to lambda raised to the power 2 upon factorial 2. Similarly, if I have to see expectation of x3, this will be equal to lambda 3 upon factorial 3. You have to see the coefficients of this.
Ma'am, can you take a question from 8.1 activity, question number 6? It is based on this concept only.
Okay, let me see.
Ma'am, I can tell you what is the question. What is the value of sixth moment of the normal distribution 0, 3?
0, 3.
Yes, ma'am.
Six moments. So you will be having the values like this. So you have to calculate the expansion.
Ma'am, here e to the power of lambda square sigma square by 2 is also there, no ma'am? I don't see that.
Sorry, what?
No, actually, e to the power of lambda square sigma square by 2. What you are expanding, no ma'am?
See, e raised to the power lambda x, the expansion is 1 by lambda x, right? Plus lambda square x square by 2 factorial.
Correct.
Right? Lambda 3 x3 upon 3 factorial. So in place of lambda lambda x, we have lambda square sigma square by 2. Right? So in place of so this would be equal to 1 plus lambda x, that is lambda square sigma square by 2. See, 2 factorial and 2 is same, right?
Yeah.
Factorial is equal to 2 only, so I've written 2 factorial.
Correct. Okay. Okay.
Then we have this whole square, right? This can be written as lambda x whole square
By factorial 2.
by factorial 2, right? So lambda x.
In place of lambda x, we have to substitute lambda square.
This will be whole square divided by 2 factorial.
2 factorial. Okay.
Right? So like that, if you solve this, you will get this formula.
X to the power of lambda to the power of 4 sigma to the power of 4 by 4
That is 3 factorial into 8, no, ma'am. Lambda power 6.
Sorry, what?
The fourth term should be lambda power 6, sigma power 6 by 3 factorial into 8, right?
Just a second. So this one, okay, that is 8. This will be equal to 15. So if you see the coefficient of 6, like you have to calculate the 6 moment. That means you have to see the coefficient of lambda x, lambda raised to the power 6 upon factorial 6, which will be equal to 15 sigma raised to the power 6, right? Is this the answer?
Yes, ma'am.
What is the answer?
No, answer is 405, ma'am. Answer is 405.
405, ma'am.
405. So
15 into 27.
Just put the value of sigma. Yeah, just put the value of this.
Yes, yes, ma'am. Yes,
Okay.
ma'am. Understood, ma'am. Thank you.
Sigma values?
Sigma
Yes, ma'am. Got it. Ma'am, I have a doubt in graded assignment also. In 8th graded assignment, question number 11.
Okay, we'll come to that. Just a second.
Okay, ma'am. Okay, ma'am.
Ma'am, can you just explain this once again, ma'am, if you don't mind?
Okay, just
Or if you can do it probably now again.
see, x is following a normal distribution 0, 3. Fine. You have to find out the 6th moment. Fine. That is expectation of x raised to the power 6. And this will be equal to the coefficient of lambda raised to the power 6 upon factorial 6. Are you comfortable with this factorial? Everybody know this? This is a factorial sign?
Yeah.
Yes.
Yes, ma'am.
So, okay, fine. So, I have to calculate the coefficient of this. So, we know that e raised to the power, the expansion of e raised to the power lambda x is 1 plus lambda x plus lambda square x square by factorial 2 plus lambda cube x cube by factorial 3. Similarly like that, right? This is the formula.
Correct.
Now, the the MGF of what do you call the normal distribution for 0, sigma square is given as e raised to the power lambda square sigma square by 2. This is the formula.
Yeah.
Correct. Now, in place of lambda x, I am having the value lambda square sigma square by 2, right?
Mm-hmm.
So in place of lambda x, I would be putting this value. Correct?
Can you come again? Sorry.
I'm just expanding this value. exponential of lambda square sigma square by 2. I'm just expanding the value.
Mm-hmm.
Okay, so this will be equal to 1 plus lambda x, like in place of lambda x, it will be lambda square sigma square by 2.
2, correct.
Correct.
Yeah.
Now I am squaring it, right?
Correct.
So this
Yeah.
will be lambda square x square by 2 whole
2
square
square
divided by factorial
2.
Similarly, lambda square x square by 2 by whole cube upon factorial 3.
Correct.
Like that, I can go on.
Right.
Correct. Now, 1 plus lambda square. Now, see, I have to, I'm writing it here. So I should have this formula, lambda expectation of x plus lambda square upon factorial 2 expectation of x square plus lambda cube upon factorial 3. In this form, I have to bring it, right? This is the general form.
Okay.
This is the general form, right?
Correct.
Right. So I should have this coefficients, right? But here I don't have that, so I have to make that coefficients, right? Correct. So this will be equal to lambda square sigma square by factorial 2. I can write it 2 factorial is equal to 2 only.
Correct.
So I can write it as 2 factorial.
Mm-hmm.
Right. Now, now this will be equal to lambda raised to the power 4, right? X raised to the power 4 upon 2 2s are 4.
8. Yeah. Yeah.
Only this much, right?
Yeah.
And this is 2 factorial.
Correct.
Now I need, see, the lambda, the power of lambda is 4.
Correct.
Right? So I have to, like in denominator, I should have factorial 4.
Correct. So we are short of 3.
So I'm, yeah, we are short of 3. So I would be multiplying it by 3 in the numerator and the denominator, right? So this will be into 3 into 3.
Yeah.
So this will be equal to lambda raised to the power 4. Sorry, it should be sigma square. This is sigma square. Okay, in place of x, it's sigma square.
Okay.
Ma'am, can you tell me how 3 came here?
See, I have to make 4 factorial in the denominator, right?
Yes.
So what is 4 factorial? 4 into 3 into 2 into 1.
Yes.
In denominator, I have 2 factorial,
Hmm.
right? So we 2 factorial means that means we have 2.
Yes.
1 is 1. So I need 3 only.
Yes.
So I just multiplied and divide 3 in the numerator and the denominator.
Okay. Right? Yes.
Right. So it will be lambda raised to the power 4 3 sigma 4 upon 4 factorial.
Hmm.
So I have got this this is good.
Yeah.
Then this one. So this will be equal to lambda raised to the power 6 sigma raised to the power 6 upon 8 into 3 factorial.
8 into 3 factorial. Yeah, correct.
Correct. Now the power of lambda is
6.
6. So in denominator, I should have the
6 factorial.
6 factorial.
Correct.
Right? So I just need to multiply it by. So
6
like
into 5 into 4.
So you have to multiply it by 7 into 6 into 5 into 4, right?
No, 6 into, not 7 is not required.
You have to make 6 factorial. Okay. So just do one thing. Yeah. Simply.
Yeah.
Just multiply and divide it by 6 factorial. That will be much more easy.
Yeah.
Okay?
Correct.
So this will be equal to lambda raised to the power 6 upon factorial 6. Okay?
6. Correct.
So this will be equal to 6. Just open it. 6 into 5 into 4 into 3 factorial into sigma raised to the power 6 upon 8 into 3 factorial. I've just taken out lambda 6 and factorial 6 out, right? So this will get cancelled. This. So this will be equal to lambda raised to the power 6 upon factorial 6 into 15 into sigma raised to the power 6. Correct? Into 5. So this is the 6th moment.
Okay.
Got it?
Okay.
Yes.
Yeah.
Everyone?
Yes, ma'am.
Sure. So
Yes,
this everybody is okay with movement generating function?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So if I'm having, and suppose like if I'm having x1, x2. Okay. If I'm let's suppose that y is equals to x1 plus x2. Okay. And x1, like suppose x1 is having like it's a moment is having a moment generating function, which is x1 lambda 1 lambda. Okay. And x2 is also having movement generating function x2 lambda. Okay. So if I have to calculate the movement generating function of lambda, this will be equal to m x1 plus x2 lambda. In place of y, I've just written x1 plus x2. Correct?
Correct.
Okay. Now, so this will be equal to expectation of e raised to the power lambda x1 plus x2.
Yeah.
Correct? So this will be expectation of e raised to the power lambda x1 into e raised to the power lambda x2.
Correct.
Correct? So I can write it as expectation of e raised to the power lambda x1 into expectation of e raised to the power lambda x2.
Yes.
Correct? So that means the movement generating function of x1 plus x2 lambda will be equal to the product of the
Moment generating function of x1.
partial, yeah, of x1 and x2. That is x1 lambda into x2 lambda. Fine. And if I say that this x1 and x2 are IID samples, then the movement generating function of y will be equal to mx lambda whole square.
Yes.
Yes. Correct? Are these both formulas correct? Like everybody understood?
Yes, ma'am.
Yes, ma'am.
Yes, yes, ma'am.
Is it fine?
Why
Yes.
ma'am? Whole square?
See, y square. Oh, see, x1 and x2 are IID samples. Okay, IID samples like which is following some distribution x of some distribution x. Okay, so y is x1 plus x2 here. So you have to calculate the marginal distribution of y. See, the marginal distribution of x1 plus x2 is equal to mx1 lambda into mx2 lambda.
Mm-hmm.
Is this formula correct? Right? You're fine with this formula?
Yeah, right.
So this I can write it as mx lambda into mx lambda. x1 and x2 are IID samples. So I can write it as mx lambda into mx lambda.
Yeah, okay.
Right? So this will be equal to mx lambda whole square only.
Yeah, whole square.
Now is it fine?
Yeah, fine.
Sure?
Yeah, sure, fine.
Okay, fine. So this was MGF. So anybody having any doubts in MGF?
No.
Okay.
No,
Now the
ma'am.
last topic comes is the CLT. Okay. So what is CLT? CLT is the central limit theorem. Okay. So what is central limit theorem? Why for what we use central limit theorem?
It's again the same similar upper bound, lower bound.
Yeah, we use it to approximate the probabilities actually. Okay, so we use this to approximate the probabilities. So if we say like, so let us suppose, so the theorem of CLT states that let x1, x2, and xn is an IID sample from a distribution X with expectation of X as 0 and variance of X as sigma square. Okay, then Y equals to x1 plus x2 till xn divided by root n. Okay, I'm supposing let y is equals to this. Then the marginal distribution of this y will be equal to or will be close to expectation exponential lambda square sigma square by 2. That means it will be close to normal distribution. This is the marginal distribution of normal 0 comma sigma square only.
Yeah.
Right?
Ma'am, here
So
sigma
it
is
is-
the
Yes,
variance
ma'am.
of x, ma'am, huh? Not variance of y. It is the variance of x.
This is the variance of X, yeah. So this is saying that if X1, X2, Xn are IID samples with expectation of X as 0 and variance of X as sigma square, and I'm letting that Y is X1 plus X2 till Xn divided by under root n. So the movement generating function of Y will converge or will be close to the normal distribution with expectation 0 and sigma square. Is it fine? This is the CLT. Okay. So this is used to approximate the probability. That means to approximate it to a standard normal or to a normal distribution. Okay. So how do we use this? So the process is like you have to just, so let us suppose that X1, X2, and Xn are IID samples from X distribution with expectation of X. Let us suppose that expectation of X is mu. Okay. And variance of X is sigma square. Then I'm letting that Y is equals to X1 plus Xn. Okay. So, so the first step is like we have to convert it into standard normal variate. So what is a standard normal variate?
X minus mu by standard deviation sigma.
Ma'am,
Normal
can you
deviation.
what is this? SNV? What is SNV?
SN
standard
standard
normal.
normal variate. Okay, what is standard normal variate? In which the expectation is 0 and variance is 1. So x minus mu upon under root sigma square is normal distribution with 0, 1 as the parameter, right? This is the standard normal variate. Correct?
We call this Z score.
Yeah, Z score. So the first step to approximate the probabilities is we have to just convert it into standard normal variate. So if I'm having a random variable y, which is the sum of all the IID samples, right? So if I have to calculate, if I have to approximate this, so this will be equal to y minus how will I convert this value, this random variable into a standard normal?
N mu. Expected value of y equal to expected value of x1 plus
upon standard deviation of y, right?
Correct.
This is the thing. Correct? So
Yeah.
this value is there. So y minus expectation of y is n mu upon what is the standard
Deviation of y.
deviation of y?
Deviation of y. I think variance of
Okay, what is variance of y?
variance of x by n.
Sorry?
Variance of
Sigma
x
square upon n.
N sigma square.
N sigma.
No, it is sigma square by n, not n sigma square, isn't it?
We are calculating for y. We are not calculating for sample mean. See, variance of y.
We are not calculating it for mean. Okay.
Yeah.
For y, it is n sigma square, correct?
Correct?
Yeah.
Okay. So this is y minus n mu upon standard deviation of y will be under root n sigma.
Correct.
So this is the value of the Z. Okay. Now putting this value and we can calculate the probabilities according to the question. So the first step is in CLT, the first step is that you have to convert it into standard normal variant. Right? Similarly, if I'm telling you my Y is X1 plus X2 plus Xn divided by N, then my Z will be equal to Y minus expectation of Y is
Y minus expectation of Y by sigma Y.
okay.
Standard
This
deviation.
is the thing. Yeah. So what are the values? Y minus what is the expectation of Y?
Expectation of Y this time is
Mu.
variance of sorry
Mu.
mu only, correct.
Yeah. And standard deviation of
Sigma.
Sigma.
Sigma by root n.
No, only sigma.
by root n. It is not only sigma. See, the variance of Y, which is variance of X bar, right? This is sample mean only. So variance of sample mean is
Sigma square by n.
yeah, sigma square by 1. So the standard deviation of Y will be equal to sigma by under root n.
Correct.
So this is the value of Z which is following 0, 1. Okay. Now let's solve this question. So this part is clear for everyone. Shall
Yes.
we move to the questions?
Yeah.
Yes, ma'am.
Okay.
Ma'am,
Sorry.
I was saying just like for this the question for the week 8, if time you discuss for the graded assignment only, because the questions over there are very. I was struggling with some of the questions.
Okay. So you want me to solve graded assignment?
No, ma'am, we solve for this only. Then
Okay, fine. See, let X be a random variable with PMF as this. Suppose X1 and X2 are IID samples from X. Define a random variable Y is equals to X1 plus X2. So what will be the movement generating function of Y? Can anyone tell me?
1/4 e raised to 0 lambda.
Okay, first of all, tell me what is the movement generating function of X?
Is expected value of X.
See,
Expected
this will
value of
be-
e to the power of lambda X.
Yeah. Expected value of.
E to the power of lambda X.
Okay. Now, this will be equal to, like, according to this PMF. So this is equal to summation of e raised to the power lambda X into function of X, correct?
Correct.
So the value of X is 0, 1,
0.
and 2, right?
Correct.
And the functions are 1/4, 1/2, and 1/4, right? So let's put the values. So e raised to the power lambda X1 is 0 into function of
1/4.
X1 is
1/4.
plus e raised to the power lambda into 1 and function of X1 is
1/2.
1/2 plus e raised to the power lambda into 2 into 1/4.
1/4.
This is the movement generating function of X, right? So I can write it as 1/4, 1/2 e raised to the power lambda plus 1/4 e raised to the power 2 lambda, right? This is the movement generating function of X. Now I have to calculate the movement generating function of Y. So if you remember, like if X1 and X2 are IID samples, right? And if I have to calculate and Y is equals to X1 plus X2. So if anybody remembers, what is the movement generating function of Y?
It's
Movement
movement
generating
Ma'am, it
generating
will be the whole square of mx lambda.
No.
Correct. Who said no?
No, moment generating function of X whole square.
Yeah. I mean, somebody said no. That's what I'm asking. Who said no? Is she having any confusion, or is it fine?
No confusion.
Okay, fine. So my will be mx lambda whole square, correct? That means 1/4 plus 1/2 e raised to the power lambda plus 1/4 e raised to the power 2 lambda whole square, correct? This will be the moment generating function of Y. Is it fine?
Yes, ma'am.
Do I need to solve this? Like, if you solve this, you
No, it's fine. It's fine.
Is it fine, right?
Yeah,
So this question is fine by everyone?
Yes, ma'am.
Okay. Now, let's go to another question.
Ma'am, one question, ma'am.
Yeah.
Suppose there are four terms in that whatever the moment generating function for y we got, and in exam, do we require to expand all the terms? Like they will be asked to.
Like, see this. Like in exam, you will be getting. It would be an MCQ. So it would be an MCQ or MSQ. It would be that longer. Like you would be getting only, I think, one. Yeah, like this only. Only 3 numbers you would be getting.
Okay.
So you
because
don't have
if 4
to,
are there, then it will be very difficult to expand the entire
you
term.
won't be getting that much.
Okay.
Like maximum 3. Don't worry.
Okay.
Okay. Fine. Okay. So shall we do the next question?
Yes.
So let x1 and x2 till x36 are IID Bernoulli 0.5. So this is the value of P. And these are all IID, right? Correct? Now, we have defined a new random variable z, which is x1 plus x2 till x36. Okay? So now, using the central limit theorem, find the approximate value of probability that z is less than equal to 20. Now we have to use the central limit theorem. So for the central limit theorem, what was the first method?
First, convert it to standard normal.
Standard normal.
Right? So this will be equal to z minus expectation of z upon standard deviation of z less than equal to 21 minus same expectation of z upon standard deviation of z. Right?
Yes.
Correct? Now, what is the expectation of z?
0.5.
Sure. See,
yes,
expectation like in place of z.
0.5 power 36.
It
will
will
get added, right?
Yeah. 36 times.
36
So
multiplied by
this will be
36 into 0.5.
Into 0.5.
correct.
So this will be equal to 18. Right? Now, what is variance of z?
That is 6 multiplied by 0.5 square.
36 into 0.25.
Correct.
Yeah. This will be equal to 9. Correct?
Yes, ma'am.
Okay. Now just we are putting these values here. Okay. So this will be equal to probability of, I am just saying this as a capital Z. Okay. Is less than equal to 21 minus 18 upon standard deviation of Z is
3.
Ma'am, are these values already given? 0.5?
Bernoulli 0.5.
Bernoulli 0.5. Okay, so that is P. Okay. So variance is also P 0.5 into 0.5. Okay, understand. Thank you.
okay. So 21 minus 18 upon standard deviation of Z
3.
3, right? So this will be equal to probability of Z less than equal to 3 by 3, which is probability of Z less than equal to 1. And in the question, it is given 0.84, right? So the answer will be 0.82. Is it fine?
Yes,
Yeah,
ma'am.
explain again.
Ma'am, this here probability z less than 1 should be 1 minus that value, no? I think answer should be 0.16 if I am right.
Ma'am, explain again. 1 minute.
Ma'am, am I right, ma'am?
No. The value of fz1 is this is equal to probability of z less than 1.
Correct. So probability of z less than 1 is 0.84. But
in the question also it is probability of z less than equal to 1 only.
Okay.
If it's greater than 1, then we will change it into 1 minus less than.
Okay, directly they have given that value. Okay, I think fine.
Yeah, directly they have given that.
So in the exam also, when there is no standard normal table given, there will be given the value of normal variable.
No, in the exam you won't you will be given the values like this. You will be given there will be different values, fz minus 1, fz minus 5, or fz 5. So you would be given the values which are useful in the paper. You would be given the values, so you don't need to worry about that. Okay, but you have to remember which value it is given. Okay.
Yes.
Yeah. So I have to repeat this question again, right?
Yes.
Okay. See, let x1, x2 till x3, x36 are IID Bernoulli random variable with 0.5 as the parameter. Okay, 0.5 is the value of p. Right? Now we have defined a new random variable z, which is x1 plus x2 till x36. Okay. Now using the central limit theorem, find the approximate value of pz less than equal to 20. Right? The question is clear?
Yeah, clear.
Okay. So using the first step of central limit theorem is converting the variable into standard normal variate. Is it?
Yes, ma'am.
Yes. Okay. So if I have to convert this into standard normal variate, I would be subtracting it with the expectation and dividing it by the standard deviation, both the side. If
Yes,
I'm subtracting here, I should be subtracting here also, right? So I'm subtracting and dividing it and converting it to standard normal variate. Now I have to calculate the expectation of z. So expectation of z is expectation of x1 plus expectation till x36, and all are IIT samples. So this would be equal to 36 into the expectation of x, and expectation of x is 0.5. Right? So this will be equal to 80. Is it fine?
Yes, ma'am.
Right? Similarly, if I have to calculate the variance, this would be equal to 36 into variance of x. And what is variance of x? P into q. P is 0.5. Q would be 0.5 only. So it will be 0.5 into 0.5, which is 0.25. So 36 into 0.25 would be 9. Now put these values in the above equation. So it would be 21 minus expectation of z is 18 divided by standard deviation of z is 3. So if you solve this, you will get probability z less than equal to 1. And above it is given fz1 is equal to 0.84. That means probability of z less than equal to 1 is 0.84. Right? So this is the answer. Is it fine now?
Yes, ma'am.
Ma'am, I'm sorry if I'm missing something, but I have a small doubt. According to central limit theorem, if the sum of the IID random variables is scaled by root n, 1 by root n, then it will be tends to normal. Am I right?
Can you repeat?
If the sum of IID random variables is scaled by 1 by root n, like sum is divided by root n, then only it will tend to the normal, right?
Yeah, it would be. Yeah.
Yeah. So here in the example, in the problem, we have given sum only, right?
Yeah.
But we are assuming it is tending to like normal distribution, and we are using the fz, etc. So
we are not. We are
if it is IID samples,
it is not.
We can.
No. This is not a normal distribution. It is not written it is a normal distribution. We are first converting it to normal, then we are converting it to standard normal, then we are calculating the value. First, you have to convert it. See, this is a Bernoulli. That means Z x1 plus x2. This is a binomial only.
Exactly.
So this is not a normal distribution.
Ma'am, actually, her question, I think, is what
is
she was
not
saying
normal.
is we need to actually divide the sum of the independent and identical distribution random variables with square root of n in order to achieve that normal distribution. No, that is what her point. If you go up, in the when you are actually explaining the central value, central
Okay,
limit,
according to the central theorem.
correct. So we need to divide it with square root of n. Then only it will approach or mimic the normal distribution.
It will approach the norm.
Is what her point, I think.
0 comma sigma square. But here we are having 0 comma 1. We are converting into standard normal. Okay, that's just a theorem. It just says that if you are like it just says that x1 x2 like here. Yeah, it just says that we are letting that x1 x2 xn are IID samples, okay, with expectation 0 and variance sigma square, and we are just letting some value y. Okay, it can be x1 plus x2 under root n. Okay, it can be anything. So we are just letting y, okay, some variable. Then if x1 plus, if I'm letting that y is this, then the MGF of this will converge to a normal distribution with 0 comma sigma square. It just says that we are just converting it, like we are just converging the marginal distribution to a normal distribution. Sorry, the y into a normal distribution.
Like like we are saying, we are confirming that y follows normal distribution here.
Yeah, it converges to. It is
the
not
variable y
converges.
It converges to normal.
Yeah.
But when and only it is scaled by 1 by root n, right? The sum is of given random samples. If it is scaled by 1 by n or something, it converges to other values, right?
Yeah, it
other
would be-
distributions.
Yeah,
In the
other
videos are explains.
Yeah. So we have to, like, according to
Yeah.
the CLT,
So my
we have
point
to approximate to the probability to a normal distribution, actually. So that's why we are first converting into standard normal variate, and this will be helpful in solving the question, because we have the standard we have the tables, right? Normal distribution table. Right?
Okay.
Yeah. So we are first converting into a standard normal variate and having getting the values. Okay. Just remember that CLT is that we are approximating it to the normal distribution. Right?
Yeah, I got you. Thanks, ma'am.
Got it. So should I move go to the last question?
Yes, ma'am.
Okay. Now, in a manufacturing company, each machine produces 600 bottles. If a bottle is selected uniformly at random, then the probability that a bottle is of good quality is 60%. Okay. So each machine produces 600 bottles, and the probability of the good quality is, that is P. We are considering P as the good quality. Okay. And that probability is given as 0.6. Right? Is it fine?
Yes, ma'am.
Now, suppose a sample of 20 bottles is selected. From these 600, we are sampling out 20. Okay. Let a random variable x denote the total number of bottles that are of bad quality. So, which of the following will be true? Can anyone tell me?
Option C.
Option C.
Option C.
Everyone?
Yeah.
Okay. Why?
Because the this probability of for the bad bottle will be 0.4. That will be our success.
Yeah, correct. And 0.4 is the probability of bad quality. Okay. Now, using the central limit theorem, find the approximate probability that a machine will produce more than 370 bottles that are of good quality on a particular. So what you have to find out probability that anyone?
X is greater than 370.
Yeah, X is greater than 370. So what is the what was the first type of central limit theorem?
Approximate to a standard normal.
Yeah. So I would be subtracting it with the expectation of X divided by standard deviation of X. Correct? Is it fine?
Yeah.
Yes, ma'am.
Just a minute. Okay, now what is the expectation of X? What is expectation of X?
0.6.
Yes.
No, I think
would be probability. Yeah, tell me.
Expectation of X is.
See, we are calculating.
We have to use the number of samples 3.
No. We are approximate that the machine will produce. We are taking the whole machine, and according to the question, each machine produces 600 bottles, and the probability that the bottle is of good quality is 0.6, right?
Correct.
So yeah, so here the value of N is 600. Correct. And the value of P is 0.6.
Correct.
Correct. So according to the question here, we have to approximate the probability that a machine will produce more than 370 bottles. So we are talking about the whole machine. We are not talking about the like the bottles.
Why N equals to 600? Where is given that N equals to 600?
In the question it is given. The machine produces.
The question. N is equals
Okay,
to
okay. Thank you, ma'am. Sorry.
Yeah. So I'm representing this as Z will be greater than 370 minus expectation of X is
360.
360 by standard deviation of X.
$144.
144, which is
12.
12. Correct? Yes. Is it fine by everyone?
Yes, ma'am.
Yes. Okay. So if you calculate probability of Z greater than 10 by 12, right? So this was probability of Z greater than 5 by 6. Yeah. Okay. And see, about the question, I think it is not given. So I suppose FZ 5 by 6 is 0.80. Okay. So this FZ, I've been given this value. So I have to calculate this value. How will I calculate?
1 minus.
1 minus.
Probability of Z. Correct? So this will be equal to 1 minus 0.80.
Yes, ma'am.
So this will be equal to 0.20.
Yes, ma'am.
So the answer, the approximate probability that it will be more than 370 bottles are 0.20. Is it fine?
Yes.
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes, ma'am.
The question is clear?
Yes, ma'am.
Yeah, this was the last question.
Yeah,
So,
can you go down, please? Yeah, we have the 12, right? It's like standard deviation is like, how did you come to the 12? 10 with 12 is right, 12. That,
The square root of variance it is 600 multiplied by 0.6 multiplied by 0.4.
okay, sure. Yeah, thank you.
okay.
Ma'am, I have a doubt in graded assignment in question number 11. Can you take up, please?
That is it. No more questions, right?
No, that was the question. So,
Thank you.
like, is it fine by everyone, the question? Like, the solution and everything?
Yes.
Yes.
Yes, ma'am.
So, nobody is having any doubts in the concept
Ma'am,
wise?
ma'am, I have a doubt in graded assignment
Yeah,
in 8
I'm
week of
taking.
Ma'am,
11th question, right?
ma'am, if you
Ma'am,
don't
can you
mind,
solve
if you
can you
don't mind,
solve tomorrow
second
PYQ?
question, we had some confusion, right? It would be really nice if you can clarify what is actually going wrong there in case you have time.
Yeah, the second question, right?
And ma'am, in week 8, we also have beta, gamma, Cauchy distributions.
No, but for quiz 2, you have to just study the MGF and CLT.
But it was there in the assignments.
Yeah, there are. It is there in the assignments, but for the quiz 2, just prepare for MGF and CLT.
Oh, Kashish is not required for this quiz too, ma'am?
No. In the
Okay.
end term, you will be having Cauchy.
Okay.
Is there some official release about it?
There is. I don't
Because
think
in the
so there is.
syllabus, they just wrote that week 5 to week 8.
Week 8, yeah. The Cauchy, the distribution is just for the, you can say.
No, ma'am, I was saying beta, gamma.
Yeah, the beta, gamma and everything. That will be helpful in, I think, week 9 and 10 in the upcoming weeks. So that's why they have just taught you the distribution.
Ma'am,
Yes.
ma'am, how was the difficulty in the question levels in quiz 2, ma'am? It will be easy or moderate?
It is just concept wise. So just read the question carefully. That's the main thing.
Yeah, okay, ma'am. Thank you, ma'am.
Maybe one question, is it like the 5 to 8 is the syllabus or 1 to 8 is what the chapters for this quiz too?
It's 5 to 1 to 4. I think 1 or 2 questions maybe.
Sorry, I could not hear clearly.
From 1 to 4, it would be coming like 1 or 2 questions would be coming. So mainly would be from 5 to 8.
Okay, sure.
Ma'am, can you please provide the sheet link of statistics too?
Sheet link?
Which ma'am have THSN and everything.
That's only there for maths too. That sheet, not for other subjects.
Thank you.
Ma'am, one also, ma'am, like till now the activity and PY grade assignment solution recording is not been uploaded. Ma'am. Please ask them to upload it. Yes, please.
Which one?
Ma'am, in the solution tab, ma'am, this practice assignment and grade assignment solution recording. After week 5, it is not uploaded.
Okay. Okay, I'll see it.
Okay, ma'am. Thank you, ma'am.
You are having sessions right now for maths too?
Yes, ma'am.
Yes, ma'am. Ma'am, can you take the question quickly, please?
Yeah, the graded assignment, right?
Yes, ma'am. Question number 11.
Okay, just a second. I'm looking into the question. Okay, for that question in which we are having the doubt, this question, right? I'm not
Yes, ma'am.
remembering from where I
Yes.
have taken the question actually. I'm not getting the thing.
Okay.
So maybe there is like in copying, I could have made a mistake, something.
No, but ideally, it doesn't matter, no, ma'am. Value can be 0.1, it can be 1, it can be 10, any value also. Ideally, we should get some meaningful answer. That's ma'am, because if whether I say less than 0.2 or less than, 2, should not make much of a difference except the probability. In one case it can be 20, in another case it can be 2 or whatever, but otherwise it should be ideally something less than 1 only we should always be getting. That's my point. I don't know where we are missing. No, sir.
I think when we convert from Chebyshev to this, we have k theta in Chebyshev, which we convert to delta in this. So that k theta, when we convert here, it would become k sigma by root n, cos sigma square by n, the whole root. So I think the k can only be 0 or positive.
Yeah, it was 0.2 earlier.
No, means if you equate it to like the Chebyshev's k theta, and if you convert it back to delta or the sample variance, we'll get k sigma by root n, and sigma by root n is coming out something 1.8. No, yeah, 1.8. And the k, if the k is positive, then delta should be more than 1.8, I guess.
No, actually, as far as I know, there's no. K can be anything and sigma can be anything actually. It is basically, we want to say how many standard deviations it is going to deviate from the mu. X bar, when we say X bar minus mu, we are saying sample mean how much it is deviating from the mu. It can be any positive value ideally.
Just a second. See, here we are calculating the upper bound actually. We are not calculating the, like, what is the probability. We are just calculating the upper bound. So
Correct.
I think it can be like 1.5 or 0.06 also.
Yeah, 0.06 is very much fine. I think more than 1 is what I am just doubtful about.
See, here we are not calculating the probability actually. We are just calculating the upper bound. So it can be
Okay, ma'am.
1.5. Yeah. We are not calculating the actual probability here. We are just calculating what is the upper bound. What is the bound? What do you mean by bound? Bound is that like below 1.5, the probability is below 1.5.
Ma'am, actually in the lecture also there, I found one slide where it is written that delta should be more than sigma by root n. It is written in one of the slides of lecture.
Okay.
Because we are converting from Chebyshev.
Can you come again? Delta should be more than?
Wait, I'll. How do I send it? Delta should be more than sigma by root n. For this to be valid, the equality. Means
Tomorrow you're having revision session, right?
Yeah, ma'am.
Yeah. So I'll clear this tomorrow.
Yeah,
Fine?
no problem. No problem. That's
okay. So what graded assignment, right? Somebody was having. Is
Yes,
she
ma'am.
here? Okay.
Question number 11.
So what is the doubt?
Actually, I solved the question, but my answer is wrong. I
What is your
marked as
answer?
0.
What is your answer?
Ma'am, my answer is e to the power lambda, e to the power c lambda plus 15 lambda plus 21 lambda square. This whole equation is in e to the power.
Three weeks, right? So it should be 3 lambda, 3 plus 15, 3 7, 7. C. See, it is given mx lambda is e raised to the power 5 lambda plus 7 lambda square, right? This was the thing. And z is 3x plus c.
Yes, ma'am.
Correct? Okay. So in place of x, we are writing z lambda, right? That is expectation of e raised to the power lambda x.
Yes, ma'am. 3 times, ma'am.
E raised to the power lambda 3x plus c. So this will be expectation of e3 lambda x e raised to the power c lambda. So this would be the case. So here this is expectation of e raised to the power. See, this is the
Lambda
expectation
x.
of 3 lambda x, right? So, so here it would be e raised to the power 5 into 3, 15 lambda plus 3 3s are 9 would be having in place of lambda square, it would be 3 lambda whole square.
Okay, ma'am.
Right? So this will be 9 sin 63 lambda square, and this would be equal to e raised to the power c lambda only.
Yes, ma'am.
It's just a constant thing, right? So expectation of constant is constant only. So this will be equal to e raised to the power c lambda plus 15 lambda plus 63 lambda square.
Ma'am, how do we get e to the power 63 lambda square? That is my doubt. Why
See,
it is 3 lambda square?
pi lambda plus 7 lambda square, right? So this is
Yes,
the
ma'am.
equation of this is mx lambda, right? So here
Yes, ma'am.
this is expectation of e raised to the power 3 lambda x, right? So I can write it as mx 3 lambda.
Yes, ma'am.
This can be written as this, right? So in
Yes,
place
ma'am.
of lambda, I'm having 3 lambda.
Okay,
So here
ma'am.
I would be placing 3 lambda.
Okay, ma'am.
And
Okay,
in
ma'am.
place
Now
of
I get it, ma'am. We put 3 lambda in place of lambda. That's why.
lambda.
Okay,
Yeah,
ma'am.
correct.
Okay. Thank you, ma'am.
Yeah.
Understood, ma'am.
Understood. Okay, fine. Anything else?
No, ma'am. Thank you, ma'am.
So is it fine for everyone? Should I end the meet?
Yes, ma'am. Thank you.
Thank you.